vehicle, we should know. According to those forces, what type of parameter we are going to improve in the vehicle, that is general description of vehicle. We need to understand that. Okay. In that, three main parameters are there. So we need to consider those parameters, and according to those parameters, we need to understand how exactly those performance will be increased and what exactly those parameters we need to understand. Before that, I'm going to show you yesterday, last lecture we have discussed regarding the environmental impact. So whatever the table we have discussed, okay, of these values, okay, these values we have discussed, similar the graph will be drawn for each of a fuel utilization stage as well as overall life cycle. These are the value. Okay, this is the graph has been drawn. Okay, for each color indicates, this color indicates the AP emission, overall life cycle. This is the curve, how exactly there is a variation, whatever the values are there over here. So these values are considered, and this graph has been drawn. So this is an environmental indicator for 6 type of vehicle. So conventional, hybrid, electric, S1, S2, S3, fuel cell, S1, S2, S3, and hydrogen IC engine and ammonia hydrogen IC engine. According to this value, this graph has been plotted over here. So if you see the results of technical, economical, and environmental analysis, so for the same we have drawn for those vehicle, different types of vehicle. So these color indicates over here, it has been given over here. Okay, so normalized general indicator, AP emission, GHG emission, fuel cost, range, and car cost. Okay, so you can see over a period of time the car cost has been gone down, and it has been, now it is increasing. So as for all vehicle concerned over here, it has been taken over here. If you can see the result of technical, economical, and environmental analysis, these are the points are there. So if electricity is generated from renewable energy sources, the electric car is advantageous to the hybrid vehicle. Okay, so it should be generated from renewable energy sources. If electricity is generated from fossil fuels, what will happen? The electric car remains the competitive only if electricity is generated on board. So these are the results. We have seen the impact of technical, economical, as well as environmental analysis. Okay, if the electricity is generated within an efficient of 50 to 60% by gas turbine engine connected to high capacity battery and electric motor, the electric car is superior in many aspects. So last point I have taken as a result for electricity generation scenario 2 and 3. Okay, so we have to scenario economical and environmental analysis as mean to store the hydrogen on board, and vehicle is to be best option among those analyzed. So these are the results for technical, economical, environmental analysis. Okay, so coming to the general description of the vehicle. So this is most important of this particular chapter. Okay, first we need to understand the introduction part of this. So also we call it as a dynamic of electric and hybrid vehicle, or motion and dynamic equations for vehicles. So many of the equations we need to write down. We have to, whenever we derive an equation for front wheel drive, maximum tractive effort and maximum acceleration for front wheel drive, similarly for the rear wheel drive. Okay, so whenever we design any vehicle, so that involves the basic principle of physics only. So we know that. So whenever you go for any vehicle design, especially the Newton's second law of motion, you know already. According to the second law of Newton's second law, we are going to consider the acceleration of an object which is directly proportional to what? Net force exerted on it. Okay, so and an object accelerates when the force is acting on it. Okay, which should be considered as a 0, 1. Then only we can say that the net force acting acting on it is non-zero. Okay, in vehicle, several forces. If you can see this particular diagram on the vehicle, several forces act on it, and the net and resultant force which governs the motion according to the Newton's second law. Okay, we are going to consider the propulsion unit of the vehicle that delivers the force which is necessary to move the vehicle in forward direction. Okay, propulsive force. So here we have to consider all necessary force according to the motion of equations, so that all which will include all the forces on the vehicle which will helps in moving the vehicle in the forward direction. Okay, so these are the forces of propulsion unit helps in the vehicle which will overcome some of the forces which are acting. Which are the forces are acting? Some of the resisting forces. Okay, why these resisting forces are acting on the vehicle? Due to the gravity, such as air resistance and tire resistance. So air resistance and tire resistance, we will consider resistance. We will consider those things according to the acceleration of the vehicle. Okay, so this acceleration of vehicle, which will be depend on what? So it will depend on the power which is delivered by the propulsion unit. What is the road condition? Okay, what will be the road condition? It also depends whether the road is a flatter one, whether the road is uneven, whether the road is hilly, whether the road is in the downward direction. So it depends on the road, also vehicle acceleration. But whenever the vehicle is moving uphill, which type of forces are acting? Okay, and the forces are resolving or not? Okay, we need to understand that. Okay, and the next thing is the aerodynamic forces. Okay, aerodynamic of the vehicle. Okay, and next thing is the composite mass of the vehicle. Okay, these are all things are very important whenever we study this general description of vehicle movement. So before going to rolling resistance, aerodynamic drag, and uphill resistance. Okay, uphill resistance. So we need to understand some of the forces which are acting on the vehicle whenever the vehicle is moving in the upward direction. Okay, so what will be the general description of the vehicle over here? Okay, so we need to analyze the force which is acting on in the direction of motion. So vehicle कौन सा डायरेक्शन में मूव कर रहा है, ये नेसेसरी नहीं है कि वो अपहिल में मूव कर रहा है या स्ट्रेट फ्लैट रोड पे मूव कर रहा है, लेकिन what type of forces are acting on it moving in the upgrade we have taken over here. Okay, it is shown in the figure, in this figure. Okay, so you can see the ft is nothing but a tractive force. Okay, so the ft is nothing but the tractive force where it is acting. So it is acting between the contact patch or contact area between the tires and the driven wheels. So tires and the driven wheels, exactly in this portion it is acting. Okay, so that is the tractive force. We can say it as the contact area between the tires and driven wheel of an road surface. Okay, so which is used to propel the vehicle in the forward direction. Okay, the tractive force is produced by the power plant. Okay, how it is produced by the power plant and transferred to the driving wheel through the transmission and the final drive. Okay, when the vehicle moves, it encounters what? It encounters the resistive force that tires to retards its motion. मतलब tractive force, anyone can tell me what is the function of tractive force in a vehicle? Whenever the vehicle is moving in uphill direction or whenever the vehicle is moving in a straight road condition. Can anyone let me know what is the function of tractive force? or you can write it in a FA or FT. FA can be written as an aerodynamic force, or FW can be written as an tractive force also. Can anyone let me know that what is the function of tractive force?
Sir, it is the ability of wheels to transmit effort without slipping.
Yes, without slipping. That will hold the vehicle on a road. Ability of the vehicle to hold the vehicle on a road. So that is the function of tractive force. Okay, so which will act? Can I ask you one question? Which will be acting in the direction of motion or opposite in the opposite direction of motion?
In opposite direction of motion.
Okay, it acts in the opposite direction of motion. So tractive force can be written as Ft is equal to in the front tire. Tractive force can be act on a front wheel drive, or it can be act on a rear wheel drive, or all wheel drive. It depends. Okay, it depends on the which type of drive vehicle you are using. On that basis, the tractive effort or tractive force will be acting on the that. Okay, so this is the first force which is acting on this particular vehicle, and second force is acting over here, the aerodynamic force, so which is acting at the front of the vehicle. Okay, front of the vehicle, which is acting at the height of HW. Okay, which is acting at the height of HW when the vehicle is moving in the upward direction. There are two reaction forces are there. Okay, there are two reaction forces. One is a WF and one other is a WR. Okay, WF and WR are the two reaction forces which are acting at this in the upward direction. So here, whenever we do a calculations, we need to find out what is the reaction force at the front wheel and what will be the reaction force at the rear wheel. Okay, rear wheel, we can call it as the reaction forces. So it can be treated as WFF or WRR. WF is reaction force which is acting at the front wheel, and WR is nothing but reaction forces which is acting at the rear wheel. And if it is moving on a flat road, okay, if it is moving on a flat road, so these forces are not resolved. Okay, so only mg will be acting in the downward direction. This is acceleration due to gravity. Mg will be acting in the downward direction because the vehicle is moving in the upward direction. Okay, the two forces are resolving over here. Okay, so one is in x direction, one is in y direction. That is mg sine alpha and mg cos alpha. So what force is acting over here? F is equal to ma. Okay, F is equal to ma. It is acting in the opposite direction. Okay, force is equal to mass into acceleration. So one force is acting towards the direction of motion. So whenever we writing an equation of motion, okay, so that we need to add that force is called as a D'Alembert's force. Okay, so that D'Alembert force is not a good practice to write down because it is necessary, and when it is necessary, in that case only we need to write down the D'Alembert's force over here. Also we can call it as a pseudo force. Okay, pseudo force. There are two forces which are acting over here at the tire. So one is a rolling resistance. That is rolling resistance. It can be treated as TR, rolling resistance. So TRF and TRR, rolling resistance which is acting at the front of the tire, and rolling resistance which is acting at the rear of the tire. Okay, so these are the two forces which are acting. Okay, when we consider this particular force, that is mass of the vehicle, so it is acting at a height of hg. Okay, hg. So this is only a single vehicle. Okay. So once we attach a trailer to this particular vehicle, again the forces will be added over here. Okay, so we call it as a drawbar pull. Okay, drawbar pull, which can be added over here, which is acting in the opposite direction. So FD we call it as, okay, FD, that is a drawbar pull. Okay, whenever we attach an trailer to this particular vehicle. Okay, so that is called as a drawbar pull. Again, one more reaction force will be add to that particular tire, which the trailer will be attached to this particular vehicle. Okay, so if we are not attaching anything, so this much, these are the forces which are acting on the vehicle. Okay, so these are the forces which are acting on the vehicle. Okay, so here we have a three resistive forces when we consider this particular diagram. So one, the resistive force is the rolling resistance. Okay, so other is the aerodynamic force, we can call it as Fa or Fw. Okay, and another is an uphill resistance. These are the three major resistive forces are there in this particular uh, vehicle. Okay, so we need to understand what exactly the rolling resistance, what exactly the aerodynamic drag, and what exactly the uphill resistance. In the uphill resistance, we have a different type. I guess all of you understood regarding how the forces are acting over here on the vehicle. These are the normal forces are acting whenever the vehicle is moving uphill. If you can consider the bike also any type of vehicles, so these are the forces are acting on the vehicle. Okay, so dynamic of electric and hybrid vehicles. So using the Newton second, so using the second law of 1 minute, I have a call. Sir, bolo. हाँ, ओरल्स क्या? हाँ, sorry, I was disconnected. Okay, so we were talking about the description of vehicle. So I'll present once again my screen. So how we are going to write down the equation by using the Newton's second law. I'm going to show you now. My screen is visible. Can anyone reply? My screen is visible.
Yes, sir.
Yes, sir.
Okay, using Newton's second law of the motion, the vehicle accelerates can be expressed as, okay, dv by dt is equal to summation of ft minus summation of f resistor divided by resistance, okay, divided by delta m, okay, where v is a vehicle speed, ft is a total tractive force. So in the total tractive force, we can divide the tractive force for the front wheel as well as for the rear wheel. Okay, so both can be considered over here. Sorry. Okay, so here m is a total mass of the vehicle in kg. Okay, and delta is a mass factor converting the rotational inner components in translation mass. This is a general equation I have shown you. This is how you are going to write down the acceleration of the vehicle can be expressed. This is how we can express. We need to understand the rolling resistance. So you can see I have shown you three figures. So we will go with one by one. Okay. So here you can see in the first figure, you can see the rolling resistance of tire on the hard surface. So on the hard surface is due to what? The hysteresis in the material. Okay. So if you wanted to understand the rolling resistance, you need to understand the material of that particular tire. What type of material is made of that particular tire? Which are the materials we use? So we use such as rubber material. Also, we can call it as an elastomer. Here, the rolling resistance of a tire on a hard surface is due to the hysteresis in the tire material. Okay, so in this figure, you can see in this particular figure, so the tire is at a standstill. ओके मतलब टायर रोल नहीं हो रहा है, एक ही जगह पे खड़ा हुआ है टायर. ओके, सो ऑन दिस टायर force P is acting at the center. Okay, the force P is acting at the center. The pressure in the contact area. Okay, so where is the contact area? This is the contact area between the tire and the ground surface. Okay, the pressure in the contact area between the tire and the road surface which is distributed symmetrically. मतलब यहाँ पे जो फोर्स एक्ट कर रहा है यहाँ पे ये symmetrically distribute है. Okay, to the center line of the resulting force. So this is the center line of the resulting force, which is PZ. Okay, PZ is aligned. So this is the P and PZ are both are aligned to each other. Okay, so whenever the tire is at a standstill. Okay, so here what we are going to see over here, the deformation Z. Okay, the deformation Z over here, you can see the deformation Z versus the load P. You can see what will be the what is the deformation when the tire is in loading condition. Okay, this is an loading condition when the tire is in unloading condition. Okay, so the deformation Z versus the force P in the loading and unloading process, which is shown over here in this particular figure. You can see this is the curve for loading and this is a curve for unloading. Here we are going to consider this point as a P1 and this point as a P2. So it can be seen that due to the hysteresis, the force P, okay, this is the force P for the same deformation Z, okay, of the tire material at the loading. Okay, the loading is greater than the unloading. Over here you can see it is greater than the unloading. Hence we can say that hysteresis causes an asymmetric distribution of the ground traction forces over here. Okay, so this is for the tire is in standstill. Okay, when the tire is at the particular portion, it is not in a rolling condition. At that particular portion we can say that. So this is the this is how we can say hysteresis curve can be generated. Okay, 1 minute. Okay, so when you see this figure, what you can differentiate from this figure and this figure whenever we study and rolling resistance, what you can how you are going to differentiate? Can anyone let me know? Can anyone let me know what will be the difference in this particular figure and in this particular figure?
Sir, the portion of wheel in contact with the ground is more, I guess.
In this particular figure?
Yes, sir.
Okay. And anyone else?
Sir, the
So
figure
the
2 includes the
yes,
eccentricity, sir. Figure 2 includes the
eccentricity. You can you can see there is A is provided over here. You can see the eccentricity is generated. Okay, so we will see what exactly it is. The scenario of this rolling resistance which is shown over here in this particular figure. So when the tire rolls, what happens? The leading of the contact area is loading and trailing. So leading and trailing half is unloading. Okay, trailing half is this one is a trailing half and leading half is this one. Okay, so here we can say whenever the tire is rolls, the leading off of the contact area is in loading condition and trailing of the contact area is in unloading condition. Okay, how exactly the pressure is distributed over here? Does the pressure on the leading half is greater or lesser? Can anyone let me know? The pressure on the leading half is greater than the pressure on the ट्रेलिंग हाफ. ओके, ट्रेलिंग हाफ पे कम प्रेशर रहता है क्योंकि थोड़ा सा मूवमेंट होते रहता है टायर. इन दैट केस इट इज लेसर. इन दैट केस an eccentricity will be generated over here. Okay, what happens? This phenomena results in ground reaction force in the ground reaction force which will be shifting in the forward direction. Okay, whatever the shift in the ground reaction forces creates the moment that opposes the rolling of the wheels. So whenever we consider this is we have considered for the hard surface. Okay, this is considered for the hard surface. So whenever we consider a soft surface, the rolling resistance is mainly caused by the deformation of the ground. In this case, this will be the figure. Okay, so this will be the figure. This is in a unloading condition. Over here the tire contact patch forces will be generated over here. So that this can be considered at this particular, this is a portion px and this is it is resolved into 2 pz and ps forces. This much of eccentricity will be there over here in this particular figure. Okay, so here we have written a rolling resistance. Okay, rolling resistance we can write it down as a P into A, or we can write it down as mg into a. So P can be written as a mg. Okay, what is TR over here? TR is a rolling resistance. P is a normal load acting on the center of the tire or center of the wheel. M is the mass of the vehicle in kg. C is the acceleration due to gravity. Okay, and A is a deformation of the tire. Over here you can see whatever the eccentricity over here is created, E is created with the help of deformation of a tire. Okay, so also the rolling resistance moment can be equivalently replaced by an horizontal force acting on the wheel center in the direction of the opposite to the movement of the wheel. So this equivalent force can call it as the rolling resistance force, or its magnitude can be written. Okay, its magnitude can be written. Okay, so to keep wheel rolling, a force that is Fr. Okay, so Fr can be acting at the center of the wheel is required to balance the rolling resistance movement. Okay, so this Fr is acting at the center of the wheel. Center of the wheel. Why it is required? It is wheel is required to balance the rolling resistance movement. Rolling resistance movement balance hona chahiye. Okay, so this is how we are going to write down that equation. Fr is equal to Tr divided by R dyne. Okay, is equal to this only can be written as Tr. We know that Tr is equal to P into A. So P into A divided by R dyne is can be written as P into Fr. A divided by R dyne is equal to Fr. So what is TR? TR is a rolling resistance. P is a normal load acting on the center of the rolling wheel. Dynamic radius of the tire, R dyne is rolling resistance. Fr is a coefficient of rolling resistance. Rolling resistance magnitude is given by Fr is equal to P into Fr. So this can be written. So where P is a normal load acting on the vehicle at the center of rolling wheel. Fr is a rolling resistance coefficient. Okay, so this Fr can be written as P into, directly I have written the equation. Okay, no need to worry about much. For understanding purpose, just written the equations. Okay, of rolling resistance. Okay, P into Fr cos alpha is equal to mg Fr into cos alpha. That is a we can write it down as a that is a wheel rolling force. So the rolling resistance coefficient is Fr. In the it is a function of the tire material, tire structure, tire temperature, tire inflation pressure, tire geometry, road roughness, okay, and road material, and presence and of absence of liquid on the road surface. Okay, so the rolling resistance coefficient, which will be the function of all these things. Okay, so whenever we are going to study the rolling resistance, in that case you are going to consider all these parameters like tire material, tire structure, tire temperature. What is the tire temperature? What is the tire inflation pressure? Okay, all these things we are going to consider it over here. So whenever we study the rolling resistance, so here this table, it can be indicated over here, this typical values of rolling resistance coefficient. Okay, what will be the typical values of rolling resistance coefficient? So you can see car tire on a smooth frame. Okay, a smooth tarmac road, the rolling resistance coefficient will be 0.01. Okay, for different conditions we have a different values. So car tire on a concrete road, the value of rolling resistance should be 0.011. Okay, and car tire on a rolled gravel road, okay, rolled gravel road, which is 0.02. Okay, and tar macadam road, which is having 0.025. Okay, whenever we consider unpaved roads, the rolling resistance coefficient will be 0.05. Bad earth track, okay, so we are having a value of 0.16. Loose sand 0.15 to 3. Truck on a concrete or alpha road, okay, which is ranges from 0.006 to 0.1. Wheel on a iron rail, okay, so which is for the rail vehicle, which is also having a very less amount of rolling resistance. You can see all the uh, truck on a concrete as a concrete which is having 0.006. If you can see the wheel on an iron rail, which is also having very less amount of rolling resistance. So 001, 0.001 to 0.002. Okay, so these are all the values of rolling resistance we have over here. Okay. So whatever the values are given over here in this table, do not take into account the variation of FR, okay, variation of FR with a speed based on the experimental results, and many empirical formula have been proposed for calculating the rolling resistance on a hard surface and for the calculation of rolling resistance on the soft surface. These are rolling resistance on the hard surface. For example, the rolling resistance coefficient of a passenger car on a concrete road, okay, may be calculated. Okay, so how we are going to calculate whenever we consider the passenger car? Okay, so one formula we are going to use, so that is I'm going to write down that formula. 1 minute. So FR is equal to F naught plus initial plus Fs final into V divided by 100. This is the standard formula for passenger car. Okay, this is standard. Okay, I have not created anything over here. This is the standard formula for passenger car on a concrete road, which can be calculated over here. Okay, so here you can see V is a vehicle speed in kilometer per hour. Okay, so in vehicle performance, whenever we consider an vehicle performance, it is sufficient to consider the rolling resistance coefficient, okay, as a linear function of a speed. Okay, so for most common range of some of the inflation pressure, okay, also can be written as also can be written as FR is equal to 0.01. This is most common thing. Okay, directly you can use this formula for the passenger car. This is the most common equation. This is also standard one. Okay, directly 100 you can write down over here. So either you can use this or you can use this one for the calculation. Equation can be used for the passenger car on a concrete road. Okay, there may be you can use similar formula for normally tar road also, or there may be different equations for the tar road. So normally this equation is used for the concrete road, whether you can consider it as a tar road also. So these equations can be used to calculate the force. Okay, variation of FR with respect to the speed, that is the rolling resistance coefficient. So can anyone let me know, so how you are going to reduce the rolling resistance? To improve the performance of the vehicle?
Good condition of road.
Yes, correct. Anyone? Anyone? How the rolling resistance will affect, how the rolling resistance will be there whenever there is a variation in the speed? The rolling resistance is more whenever the vehicle is speed is more or less?
Less, sir.
Yes, tell me.
Sir, rolling resistance is more when the speed of the vehicle is less.
Yes, rolling resistance is more when the speed of the vehicle is less. Rolling resistance is lesser when the speed of the vehicle is higher. Okay, so this plays a very important role in the vehicle performance. Okay, so the rolling resistance should be that only to improve vehicle performance. So whatever the this whatever I have mentioned over here, all these things are important in improving the performance of the vehicle, improve the performance of the tire. Okay, which improve the rolling resistance coefficient. Okay, this is the first resistive force we have. Okay. Second will be the aerodynamic drag. Okay, so what is the aerodynamic drag? Whenever the vehicle is traveling at a particular speed in the air and encounters a force resisting its motion, this is known as a aerodynamic drag. Okay, so we know that aerodynamic drag can be a shape drag or spin drag. It's very important. Nowadays, everybody is going towards to improve the shape. Okay, shape. That means on the vehicle, the air can be easily flown. It should not create a drag between the vehicle and the air. Okay, if it is creating a drag, then it is very difficult to move the vehicle in the forward direction. Okay, so that's why many of the industries, many of the manufacturers are concentrating towards improving the shape of the vehicle so that how they are to reduce the drag of the vehicle. So there are many tests are there in aerodynamics, wind tunnels called as. So it is available in the VT college wind tunnel test. So you can create a dummy model and have a test on your vehicle. So that is a tunnel test. So in the aerodynamic drag, we have two types of drags. One is a shape drag and second one is a skin effect. So what will be the shape drag? Shape drag is due to the shape of the vehicle. How exactly shape? According to that, it depends. Shape drag. Okay, the forward motion of the vehicle which will pushes the air in front of it. Okay, the air cannot instantly move out of the way and its pressure is thus increased. Okay, this results what? This results in high air pressure in front of the vehicle. Okay, so depending on the shape, it creates a pressure in front of the vehicle. If the shape is not properly designed, okay, the more and more pressure will be created in front of the tire. Okay, here what it will do, this results in a high air pressure in front of a vehicle, and behind a vehicle that much of not pressure will be there. Okay, so behind the vehicle it cannot be instantaneously fill the shape left by the forward motion of the vehicle. Okay, so also high pressure zone in front of the vehicle opposes the motion of the vehicle. Matlab it resists the vehicle to move in the forward direction if the shape is not properly designed. Okay, so in the aerodynamic, the first type we are having a shape drag. On the other hand, low pressure zone developed at the rear of the vehicle. Okay, व्हीकल के पीछे उतना नहीं क्रिएट होता है एरोडायनामिक प्रेशर, थोड़ा सा कम रहता है जो भी व्हेन वी कंपेयर front of the vehicle, so there will be a less amount of pressure will be at the rear of the vehicle. Okay, so this is called as a shape. कैसा shape है vehicle का shape? As the name indicates, skin effect. Okay, so skin effect भी जो अपना स्किन रहता है, इट डिपेंड्स ऑन द स्किन ऑल्सो, मतलब लेयर जो होता है व्हीकल का लेयर, वो कैसा मतलब डिजाइन किया रहता है व्हीकल का लेयर. ओके, सो हियर द what is the function of skin effect over here? The air, whatever the air is there, that will be close to the skin of the vehicle, which will be move almost at the speed of the vehicle, while the air away from the vehicle remains still. मतलब कितना क्लोज से मूव होता है एयर व्हीकल के स्किन के साथ, तो उतना ज्यादा एरोडायनामिक इफेक्ट ज्यादा होता है. ओके, between the two layers we have a two layers over here, the air layer moving at the vehicle speed, and the another is the static layer. Okay, air layer as well as static layer. Air layer is a normal air, and static layer which will be comes on the skin of the vehicle. Okay, whatever the molecules move according to the different speed or variation in the speed of the vehicle. So whatever this different speed is there, no, that will having a air molecules. What will results these air molecules? This results in the production of friction. Friction create करता है. This is the skin. Skin will be it will results in creation of the friction. Okay, this friction results in the second component of the aerodynamic drag. Okay, that is known as a skin effect drag. Whenever we consider this drag, which can be expressed by this particular equation, okay, so Fw can be expressed, so that is the aerodynamic force or aerodynamic drag, so that can be considered as a half rho AF CD V square. मतलब ये खाली फ्रंट एंड के लिए है. So whenever we study the aerodynamic different forces which are acting, so मतलब साइड फोर्सेस कौन से एक्ट होते हैं, मतलब जब भी व्हीकल यॉ होता है, बाउंस होता है, पिच होता है, इन दैट केस देयर आर डिफरेंट इक्वेशंस आर देयर in the case of aerodynamic forces. So this is only for the front. Okay, so rho half rho AFCD V square. Rho is the density of air in kg per cubic meter. AF is a vehicle frontal area, V is a vehicle speed, and CD is a drag coefficient. Okay, so this is the equations we use to write down for the aerodynamic drag. Okay, so usually manufacturers are trying to reduce the drag force so that vehicle will be having more and more performance. Okay, so you can see which are the vehicle are having. Which are the vehicle are having the different drag forces. Okay, so CD is nothing but CD is nothing but the drag coefficient, and AF is nothing but frontal area for some type of vehicle. So we will see in the next lecture. We will stop here because I have a meeting at 3:30. Okay, so we will stop and we will continue in the next lecture. We will study these values for which vehicle, what is the drag coefficient, and what will be the frontal area for the some type of vehicle. Okay, you can give your attendance. I'll put in the chat box and you can exit.